Very good morning. Welcome you all to this NPTEL course on Advanced Distribution System Analysis and Operation. And the previous class we have understood the TSO-DSO interaction, and today probably we'll get into the bidding mechanism, the market structure, different DSO markets do exist. So all those architectures we'll be discussing today. Now, when we talk about bidding mechanism for DSOs, that means how bidding process can be taken care within a DSO. Now, there are different DSO bidding models which are being practiced at different regions, different countries, and we'll look into the current industry perspective, what kind of bidding structures are being practiced. So, we have different DSO models. All of you please have a look. So, the DSO models, when you see, there are different types where we talk about TSO only, TSO hybrid, distribution node utility, distribution node independent entity, peer-to-peer utility, and then peer-to-peer independent entity. Now, looking to transmission, which is a highly centralized wholesale, local distribution area, which is a middle ground nodal, and peer-to-peer is highly distributed local. So, let us get into those models very slowly. Before we get into the bidding mechanism, some of the definitions we must understand. Okay? So, the stakeholders include ISO, which is an independent system operator, utility means a distribution company or transmission companies, distribution grid operators, DSO, and then distribution grid operator, DGOs, a distributed market operator, that is a DMO, and distributed energy resource manager, DRM, which is very, very important. Please remember, DERM means distributed energy resource manager. And consumers, producers, third party aggregators. So, first of all, let us understand what is TSO. TSO is responsible for real time operation of the bulk transmission system and operation of a competitive wholesale power market within its jurisdiction. Also responsible for long term transmission planning. Now, utility, which is responsible for the ownership, field operation and maintenance of the infrastructure and equipment of the complete electric distribution system. DERM, distributed energy resource manager, very important, responsible for the monitoring, management, coordination and optimization of numerous DR owned and operated by the utility, independent producers or aggregators. DMO, which is quite important, responsible for managing, DMO means distributed market operator, which is responsible for managing a platform for utility and third party bids, offers and bilateral transactions for distribution services, as well as transaction clearing and settlements. Underlying assumptions include the concept that the DMO cannot also participate in the market it operates. The utility will continue to own the distribution grid assets and networks, and the utility will remain responsible for safety and reliability of the distribution network. And in case of aggregator, which basically transact with multiple consumers, as I told you earlier, and or producers to aggregate the transact bundle energy services for delivery to the DSO, utility, or even to the TSO. And then producer provides energy services from connected distributed energy resources and related equipments. Customers, very clear, you all are customers, purchases energy services to serve grid connected equipment and appliances, that is your load at your residences or any industry consumers, or probably it could be organization, institutions, and majorly residential consumers. Now, let us talk about the first model, TSO only. What is TSO only? A highly centralized model where the ISO TSO is responsible for the DMO and DERM under its jurisdiction, including the DR on the utilities distribution network. So please focus. So this is my TSO. Okay. In case of a TSO only, TSO will act as a DMO or DRM, and utility, it is the distribution grid operator. It might own DRs and participate in the wholesale market. Now, at the end, what happens that the DRM and DMO, these are the elements which manage actually manage your DRs, and DMO, it is the market operator of the wholesale market. At the end, we have aggregator, producers and consumers. They own DRs and participate in the wholesale market. So could you see the structure? Because the terms like customer, producer, aggregator, DMO, DRM, utility, TSO, I think these are the elements present in any power market, okay? And their arrangement and operation decides what kind of model they operate, all right? So moving to the next model, TSO and hybrid utility. So here what is happening, it is a highly centralized model where the DMO is managed by the ISO, but the DRM is managed and coordinated by the utility. So in the previous case, if you see, the DRM could be a TSO, but in case the DRM is managed by the utility. That means the TSO is only the DMO. Utility, the DRM is part of the utility now. So it is the DRM and managed grid operation of the distribution network. It might own DR and participate in the wholesale market. And again, DRM manage DRs, and DSO itself is a DMO, and they own DR and participate in the wholesale market. That is your aggregators, producers and customers. Now let's move to the model number 3, which is popularly known as distribution node utility, a nodal model that uses locational marginal pricing LMP at a physical distribution constrained location such as substation or feeder. The utility is responsible for both the DMO and DRM. So what is going to happen now? The TSO is going to be TSO itself. However, the utility become either DRM or it could act as a DMO and manage your distribution network grid operator. It might own DR but cannot participate in the distribution nodal market. All right. So again, DRM, which is managing your DRs, DMO is the market operator of distribution nodal market, and the following aggregators, producers and customers can have their own DRs. So the structure is slightly shifting, okay? Model 1, model 2, model 3, 3 models. But if you see, the responsibility of TSO and utilities are slightly different. Moving to model number 4, this is distribution node independent entity. So in this case, there is a new entity which has been created known as independent entity. So a nodal model that uses LMP at a physical distribution constrained location where an independent generation or an independent organization operates the DMO and the DRM on the distribution grid. So model 4, which is my distribution node independent entity, a nodal model that uses LMP at a physical distribution constrained location where an independent organization operates the DMO and the DRM on the distribution grid. So if you concentrate on the block independent entity, now previously my TSO is either DRM or DMO, or utility become DRM or DMO, but now this independent entity act as a DRM or DMO, TSO remain TSO, and utility it manage the distribution network grid operation, and it might own some of the DRs if possible. And then you have your management of DR through DRM, market operator of distribution nodal market through DMO, and rest of the aggregators, producers and customers can have their own DRs. Now we'll move to model 5, popularly known as peer-to-peer utility, a highly distributed peer-to-peer market where the DMO role is owned by the utility. Very important. DR dispatch is performed automatically by the customer and aggregator based on market activity. So you can see the TSO remain here. Utility, it is the DMO, very important, and manage the distribution network operators. And then you have a DMO, which is market operator, but the DRM, which is missing here because the DRM block, which is under question. Now moving to model number 6, peer-to-peer independent entity. So it is a highly distributed peer-to-peer market where the DMO is managed by an independent organization and DR dispatch is performed automatically based on market activity. So the independent entity, which is my DMO, and we have TSO and utility manage the distribution and network grid operation, the DMO market operator for peer-to-peer marketplace, and aggregator, producer, customers, they own their DR and participate in the peer-to-peer market as well as for self-dispatch of their DRs. So after looking into different models, we can move to ancillary support from distribution grid to transmission network. So when we encourage a lot of flexibility, so the ancillary support to the distribution system do have, can help the transmission system to take advantage of the ancillary services that can be obtained through the distribution system operator to the transmission system can be looked into. So first of all, what is ancillary services? So ancillary services are value added services required for maintaining generation and load balance, maintaining voltage and reactive power support, and finally emergency preparedness. Okay. So ancillary services can be provided either by your generators, distribution utilities, and transmission operators. Ancillary services dispatched by system operator maintaining generation and transmission reserves need to define, measure and pay for services that is regulated market. So through ancillary services, we can experience voltage control, very important, frequency control, equally important, and then system restart and stability control through ancillary support. So ancillary support, we can gain system stability, we can have frequency support, we can also have voltage control. So if you classify, so ancillary services are majorly classified into frequency control, voltage control and black sat. And frequency controls are of 3 types: primary frequency control, secondary frequency control and tertiary frequency control. So ancillary services remuneration. So whenever there is an exchange of energy, so why do we provide ancillary services and who mandate those services? So when I talk about ancillary services, so first one is going to be primary frequency control. So when I carry out primary frequency control, which is mandated by grid code, secondary frequency control, which is regulated through secondary reserve ancillary services, and tertiary frequency control, market based through tertiary reserve ancillary services. Voltage control as at 5 paisa per kVARH, escalated at 0.5 paisa to kVARH per year. Black stat at 110% of charges for deviation for last, black stat at 110% of charges for deviation for last block in which grid was available. Energy market versus ancillary market. So the comparison, energy market to ensure basic load generation balance, ancillary market to ensure frequency control. Now 15 minutes average megawatt is produced by stakeholders through buy and sell. Up and down reserve capacity megawatt is produced or procured by system operator. Now in case of energy market, market cleared at power exchanges, but in case of ancillary market, market clear at system operator level. Now in case of energy market, certainty of dispatch, but in case of ancillary market, dispatch is not guaranteed, only when needed. Now no opportunity cost for energy market, however there is a opportunity cost to the extent of non-dispatch, that is 20 paisa per kilowatt hour. As an example, these values may vary from system to system. Thank you very much for your kind attention. Hope you have enjoyed different DSO models and how do they operate, and especially the ancillary support to the distribution system operators. Thank you. Bye-bye.